Hey, WebAssembly friends. Thanks for tuning in to another episode of Fermyon Live. My name is Torsten. I'm your host and demo guy as of today. So the intention of Fermyon Live is to give you uh, insights and examples and ideas how you could build um, all kinds of different workloads using Spin and WebAssembly, and how you could leverage different runtimes that we or the community provides. So that said, we are always curious to learn more about our audience. So you're welcome to join the chat and let us know where you're tuning in from and how your week is so far. Um, for this episode, I thought about going back a little bit to the basics. So um, building custom Spin templates, because I think that's a super underrated capability that Spin provides. And the bigger your team is, or the more workloads you're building with Spin and WebAssembly, the more value you could get from rolling your own templates to, for example, jumpstart building a new application, or to ensure regulatory compliance across different workloads that you build, or maybe across different teams that use Spin to build applications. So that said, let me bring up my screen over here. It's all about, as I said, creating custom templates for Spin and distributing them. We have documentation for that in place as well. So let me bring in a nice banner over here, and also put the link to the docs into the chat. So with that sorted out, the intention is to start from scratch. So I created a simple Git repository on my GitHub account over here. It's public. There's nothing in there besides a README file. And throughout the stream, we are going to create a custom template that all of you could use when building an app with Spin. So again, let me grab that URL and also share that in the video and in the comments. So repository is over here, so you guys can follow along and see what we're building during that session. Awesome. So let me quickly hide the banner again. And let's get started. If you have Spin installed, so let's do a Spin -- version. So I've installed Spin 3.1.2, and let me bump the font sizes a little bit. Spin itself comes already with a bunch of templates pre-installed. So if you do a Spin new, you have like a wizard guiding you through the process of creating a new Spin project. And as part of that, you could choose one of the pre-existing or of the existing templates that we created or the community created in order to get going pretty fast. So as JavaScript and TypeScript are super popular programming languages, I thought about creating a tailored version of the HTTP TS, so the TypeScript template that you already have on your system if you have Spin installed. And the idea is to make it a little bit more maybe rich, to bring certain features or lay out a project structure so that coworkers or maybe also yourself could participate from having that tailored template when building another application. There are plenty of samples out there how to create, or how, plenty of templates out there that you could use as a template for creating your own. But I want to do everything manually. So let's open up the folder in VS Code, and let's also bump the font sizes over here. Oh, no, not that much. I think this should be enough. So on a high level, we are going to, we have to distribute templates in some way. This could either happen through like a directory. So you could, for example, have a central place in your organization, maybe a file server or something like that, where you can install templates from. You could install them via HTTP or by leveraging Git. So the idea is to have like a local directory for the inner loop, and at that point in time, when we're confident with, hey, this template adds value, we can push it to GitHub, and then others can consume the template by simply executing a spin templates install command. And we'll go through that cycle a couple of times during this episode of Fermyon Live. All right, so first of all, you need like a Git repository. As I said, I created one, and within that repository, you need a templates folder. So that templates folder also contains or must follow like a pattern. So first we need a folder for a particular template, and let's say we want to roll a CRUD-TS template. So the idea is to give like a pre-configured template when building CRUD, so RESTful APIs with TypeScript. So every template must or consists of two top-level folders. First, we have a metadata folder over here. And second, and right now VS Code should render things a little nicer. We have nope, that was wrong. And I always struggle with that way of representing folders in VS Code. So we need a content and a metadata folder. The metadata folder essentially, so in its simplest form, metadata folder just contains a manifest file that's called spin-template.toml, where we will provide essential information about our template. And as you may already imagine, content will contain all the files that the Spin CLI will generate when we use that template to create a new application. On top of creating new applications, Spin templates also support adding components to existing Spin applications. You may have stumbled upon this. A nice way of leveraging that capability is to create a project using the HTTP empty template and then adding multiple components that may listen to different routes using the HTTP trigger to incoming requests. So this is super useful if you, for example, want to build an app that consists of one component responsible for serving like a single page application or a simple HTML5 front end, and a dedicated API that can do the heavy lifting for you. So we will take care about the content in a second, but first let's create the spin template.toml. Again, moving over to the docs, so you get like hey, this is how a template, the manifest could look like in its simplest form. And we want to use like those capabilities over here. And let's say this is our CRUD-TS template. And let's say our CRUD API in TypeScript, or maybe let's say a RESTful API in TypeScript. Tags, we could say, for example, TypeScript and APIs. So those tags are mainly used in the Spin hub to organize certain things, and they're also shown or printed as part of the CLI experience when inspecting or listing different templates. So we have we have an ID, we have the description, and obviously we could specify parameters over here. So maybe let me move over to the terminal again, and let's do a spin new, and let's say I want to use ts a hello spin. Oh no, that was wrong. Hello spin, and let's not accept the defaults. So you see the spin new experience asking me several questions. Those are basically configured using parameters in that case, the HTTP TypeScript template. So we can define our own like parameters, and the spin CLI will ask the user to answer those questions and fill in the parameters, which we could again use in the content files to generate meaningful content for that particular application. So let's cancel that and let's bring in like the default parameters. So those are parameters that you may know already from other templates, like for example TypeScript. So we want to ask the user for a project description that should be optional, and for HTTP path, because the RESTful API is also triggered through an HTTP, through an incoming HTTP request, and we could provide patterns. So in this case, it's a regex that says, okay, the value or the answer from the user must start with a forwarding slash followed by a non-white space character, and that's obviously saying unlimited. So it doesn't matter if it is one non-white space character or 10 or whatever. So to have that value align with a route or an HTTP path in that case. Okay, so this is for its simplest form enough for the for the template manifest. However, I quickly mentioned that you could build spin apps using multiple components, and let's maybe demonstrate that experience. So let's go there and let's say spin new http empty a Fermyon -live. So by using the HTTP empty template, I get a Fermyon live folder over here. And if we take a look at the spin toml file, you can see there's nothing in there, right? There's no component, no trigger, nothing in there yet. And from now on, I can simply do a spin add over here. I can choose a template. Let's say, for example, static file server should serve as my front end over here. And the HTTP path should be everything under the root route. And I will, let's say front end is the folder where my static assets live. So if we now take a look at the folder structure over here, you can see we still have the spin toml, the git ignore, but now we have a front end folder. And that would basically be the place where I create a touch front end index HTML, where my website resists. And looking at the spin toml file, right now I have a trigger and a component linked to that trigger. So this is basically the adding component to an existing application experience, which we could also support for our custom template. So again, let's do that one more time over here, and let's pick HTTPTS, and let's say this becomes my API, and it should listen or respond to incoming requests with the path prefix API and everything underneath that. So now we have a new API folder. This is basically where my TypeScript component or the source of my TypeScript component resists. And again, looking at Spin Toml, we can see right now we have two HTTP triggers, right? So this is a slightly different experience from Spin New, because with Spin Add, we don't replace or generate an entire Spin Toml. Instead, we just take a fraction, the trigger, and component-specific instructions like, hey, this is where you can find the component. These are like component capabilities that we want to specify on the API component. And if I hit space right now, we also see those are the build instructions for that particular component. So in the case of HTTPTS, when adding a component using that template, only this subset is added to the existing Spin Toml instead of rolling a custom Toml from scratch. And that's what we want to mimic. And to do that, Spin templates over here. And to do that, we have to update our manifest and say, hey, generally speaking, we want to have support for adding a component, okay? And we want to skip files. So we can tell the Spin CLI, hey, if the user executed a spin add and choose this template, please generate all the files specified in the content folder with the following exceptions. And we know for a fact right now that we don't want to generate a Spin Toml file, because if someone adds a component, the Spin Toml file is already there. So now the next question is obviously, okay, but how could we then inject the custom like trigger and the component configuration and the component build instructions in that case? So there is another configuration table over here that we can set, that's add component dot snippets. And this is basically telling the CLI, hey, if it is an add component operation, please use the following template or snippet and apply that. Component, yeah, equals component.txt. All right. So where does that snippet resist? Well, the snippet is a folder in a subfolder in metadata. So here is snippets, and within snippets we mentioned a new components.txt. All right. So before before taking care about that add component experience and filling out the component.txt, I think we should create the content. So that what we actually want to, stamp out when someone uses our template. It's just me right now adding the add component configuration over here, because with that, our manifest for that particular template is done. So that's feature complete, so to say, and we don't have to care about that anymore for the sake of this stream. So right now it's us basically adding files and folders and stuff to the content folder. So we could create those files manually. However, there's a smarter way of doing that. So let's go to the templates folder, and there's the CRUD TS. So this is basically us right now being exactly in this folder over here. So let's remove the content folder for remove dir mmrf content, and let's recreate it by using spin new thttp ts, accept the defaults, and call it content. So I'm just using spin to say, hey, create me a new app using the HTTP TypeScript template, accept the defaults, and call it content. Meaning that we right now, if we move back to VS Code, we have everything in place that we need or that we want our template to generate for new projects using the CRUD-TS template. However, we must, bring in some tokens in order to make it look or to respond to the user input, so that we end up with every new application using the name provided by the Spin New experience, taking in the HTTP path into context and the description, and so on and so forth. But before that, I want to tailor the actual code that will be stamped out by the template. So by default, an HTTP TS or an app created using the HTTP TypeScript template looks like this. That's the source code that you end up seeing when you use Spin New or Spin App, Spin Add, and choose that template. So we already have a router, so we use the ET router with the latest Spin SDK for TypeScript and JavaScript. However, there are like some simple samples to ensure users get going with building CRUD APIs. But we could do better, right? We want to lay out a CRUD template so that it's super convenient to build a new CRUD API with Spin. Let me quickly open. So let's go to the content folder. Let's do an npmi. This is just me making VS Code happy and to make those squiggle lines go away. So once we've installed all the dependencies, we can implement how our template should look like, and then we will clean it up and tokenize it. So let's open up this one again. Let's go into source and let's start laying out the API. Let's get rid of the sidebar and let's roll with that. Let's say our API should, we can replace this with the path experience, could we? We could to some. Let's say, for example, we say this is products. So we have a get products, and let's call this get products or get all, like this. And next one would be products : ID. So we grab the ID from the route and want to call get by ID, pass in the ID. Next is post to products. And let's say this is async. We grab the request and then we want to create. We want to create a new product. And as part of that, we want to await request.array buffers, because we want to, take the payload of the incoming post request into context for creating a product in our data storage of choice. So let's copy that. We have also put at ID, and we want to have the ID over here as well. This is an update by ID that takes the ID and the array buffer. And last but not least, let's take this one and paste that over here. So this is a delete, and let's say delete by ID, get rid of the hello world handler, and there we go. So this is basically the layout of our CRUD or RESTful API. And right now it's us implementing these handlers. So let's say products.ts. We want to have several exports over here. So let's say export const, what was it? Get all equals returns a response over here. And oh no, that was the wrong programming language. So that should be like this. We have to bring that, yeah. Return new response null 200 status 200 for now. All right, that was wrong. Let's copy this one. Let's paste that 4 times and customize it. So get by ID is the second handler that takes an ID, which is a string, and that should return a response as well. Next is creating. This is an async function. So async, there is the request body, which is an array buffer over here that must return a promise of response. Update by ID is as well async. We said we want to receive ID as a string, body as an array buffer, and return a promise of string again. Last but not least, we copy this one because we also want to have a delete by ID. Okay, now we can make index happy again by bringing all those functions into scope. There we go. So now our index.ts is already happy, right? We have laid out the overall API surface. We have, or we are pointing each and every request like, now basically we're linking every route registration to a particular handler. Some of them are sync, some of them have to be async because we are asynchronously reading the request payload and passing that down into, into our handlers. Okay, so let's move to the implementation. And for the sake of simplicity, let's say we are using a SQLite database over here. So we go to our Spin tunnel over there, and we say SQLite databases equals default. So we give the component the permission to interact with that SQLite database. And then it's us basically using the Spin SDKs to, is it DB? No, it's SQLite dot open default connection. So now we can say db dot execute select, I don't know, ID, comma, name from products, and this is an empty array for this command, so we get back a query result equals that, and then we iterate over that query result map query result rows dot map row. We take the row and we say for every row return a new object as product. So we create a new interface over here, export interface product that consists of an ID, which is a string, and a name, which is a string. Maybe the ID is a number. Number. All right. And next we say the ID is row, and now let's say add ID, and we can simply cast that as number over here and bring in the name, which is a row at place name. And that we will set that to not allow null values in the database. Okay, so this gives us our const products. And with products in place, we could simply say, instead of using return new response, we could say return JSON. So JSON is a function exported by the ED router that takes an arbitrary JSON object as the first argument. So we can say products. It sets the status by default to 200, and it ensures proper HTTP content types are also set. So HTTP header. So the content type is set to application JSON. Alrighty. With that, we could look into ID, getting a product by its identifier. So first, if not ID, then we could say, so ID is a string. Yeah, let's roll with a string. We relate it out as string. Okay. So if we receive an empty identifier over here, we return new response null, or let's say bad request, and set a status to 400. Sorry. If so, we try to find the product by its identifier. So we say const db equals SQLite open default query result equals db execute select ID name from products where ID equals question mark, and pass in the ID as a parameter over there. And then we can say if query result dot rows dot length equals 0, then we return new response and set the content to not found status. I think there's also a shorthand for that one in ET router. But anyways, okay, so if there is at least one row, we say const found equals as product. There we go. And we set ID to be equal to query result rows at 0. Oh, do we have an index over there? I think so. I think we should have an indexer. Rows that. We'll see. ID and name query result rows at O at name. Like this, and again return JSON with found. All right, this is get by ID. Create, we have to basically turn the array buffer into a JSON object and then store it in a database. So we could say const new text decoder over here. Say const payload equals JSON parse decode body. And we could do some poor man's validating over there. So if not payload or not payload payload dot name or not payload dot ID, then again return new response bad request status 400. Oops, reset the zoom is not what I wanted to do. Okay, if the payload is valid according to our validation logic, we then want to take again const db equals SQLite open default db execute insert into products ID name values and bring in ID, payload, ID, payload, name. Obviously, this would be the place where you may not want to trust. You may not want to trust the client in sending you, oh, let's remove that and let's do that on our own. So let's roll a new const ID client equals to UUID. Let's roll a new UUID. So that would be us basically using UUID npm package over here. So we could take this one, go down below in content and do a npm install. Do a npm install. So this will also bring our package JSON in shape, right? So that every user of our component will end up with the right version of UUID already being pre-populated to their project that they created using our template. All right. So ID, let me quickly check the API of UUID. Import v4, this looks pretty good. Let's go there and let's grab this one. So instead of trusting the client when receiving a new product, which you shouldn't do, we roll the ID on our own and then we use that to store that information in database, right? We can span this with a try catch error and return new response internal, because we don't want to leak in implementation details. We say internal server error over here, status 500. But we can obviously console log error while storing new product, and we could log the error. So this is this will basically go to the standard out, and so we can see that when running the app. However, we don't want to leak implementation details like the stack trace or the error message to the consumer of our API. Yeah, and simply, terminate with an HTTP 500 if something goes wrong. If everything is great, then we simply return, for the sake of this not workshop, this live stream right now, we return a new response and say created, or maybe we can simply compute that. We can say as product, or we can say JSON. We set the ID to ID and the name to product payload dot name. And on top of that, we set the status to be 201, and we want to add a new header over here that says maybe location. Location is something that you want to provide, and that would be products at, and then again ID. And to be better safe than sorry, let's set content type application JSON over there. And now let's double check where I messed up things. Oh, that's not new. That's just a function. Oh, okay, like this, right? This could be like a super simple handler for inserting data into database. If something goes wrong, we simply return back a 500. If the user provides a payload that does not, that's either empty or that does not provide a name field, and a name field must be more than an empty string, then we return back an HTTP 400, indicating that the user made some, or the callee made something wrong. All right, update by ID and delete by ID. Let me quickly copy the validation logic over there to save some keystrokes. Or we can also try to take the catch. There we go. So we have the common pattern over there. We check if the name is provided, and let's say so there are different ways of achieving an update. So the simplest one, however, having the slowest latency is going to the database, checking if there is a product with that particular ID. If not, returning a 404. If there is one, we could do the update. We could combine both SQL statements and basically update and select, or we could look at affected rows. There are different ways of achieving that. But for the sake, again, of simplicity, let's say update products set name equals question mark, where ID equals question mark, and let's bring in payload dot name, and the identifier is we receive the identifier from the route parameter, and let's check this as well. Okay. Why did I make that async? That makes no sense. This handler does not have to be async at all. Can make that sync. Same applies for create. Okay, return a response. Yeah. Okay. Cool. So we are lacking the response statement over there. Return new response. Then we would simply pass back as product again. Again, JSON. ID equals ID, name equals payload dot ID. Okay. Yeah, there's room for improvement in the handlers, and I guess the same would apply over here. The only difference is we don't accept payload for deleting an item. We just double check if the ID is provided, right? And we say delete from products where ID equals question mark, pass in the ID. If things go as expected, we return a status code, which is 204, meaning no content, and otherwise we return this error, we log that error while. Okay, so this could be like a potential implementation of our CRUD API. I don't want to go too deep into all the nitty-gritty error handling details for now, because it's more about rolling this as a custom template. Okay, so let's ensure this one builds spin B. So we are building it. It builds. Yes. Could we do a spin up also? There we go. Obviously, I haven't populated the database schema, but yeah, bear with me. That should be self-explaining. Okay. So this is our content folder. Now let's do some housekeeping over there. We don't need the build folder. We don't need the dist folder. And we don't need the node modules folder, right? Those are artifacts that are, and the .spin folder is also not necessary. Those are artifacts generated on the user's machine once he used our template to do a spin new and to generate a new product, and once he executed spin build. However, we definitely wanna customize how two things look like. One is spin toml, because this is right now hard coded with content and my name over there. So it is us basically bringing in either pre-existing tokens. So authors, for example, is one that's is able to fill in the name, because that's something you have to specify when using the spin new CLI. And on top of that, we can now use those individual parameters that we defined, right? So we go to the spin toml, that's the one that will be generated, and we fill in the blanks. So the blank is this, basically, the description. And we have the HTTP path. So this is used in the trigger configuration. So we can say, hey, this is the route. The route is defined by using the HTTP path parameter that we ask the user to provide a value for. So for component, we have that project name, right? Because you have to enter a project name when doing spin new. However, casing is something that we have to manage when scaffolding those files or artifacts. So in the case of the component name, we always default to use a kebab case representation of the project name. And this is wrong. This should be double quotes. Sorry. So let me copy that because we need that a couple of times, right? We have the component name over here. We have it in the configuration table. We have it over there. And right now, VS Code is not happy with that because it's not valid toml, but it is a template, right? So where else? In the dist folder, we also want to use the kebab case representation. We want to exclude files, yes, and we have our individual configuration to immediately grant the app permission to a SQLite database. This looks pretty good for spin toml. So there's one more file that we have to customize, that's package.json, because there's a project name as well. And we also want that one to get kebab cased. We want to leverage the, project description parameter over there. And last but not least, there is a build command over here, using all the dependent tools and the tool chain to turn your JavaScript or TypeScript source code into a WebAssembly module. And this, again, if we scroll to the right-hand side, at some point we say, hey, go there and create a file that's called content.wasm. Obviously, that should be the kebab case representation of our project name. Cool. That's it. Right? This is our template. There's only one thing missing. That's basically filling in the component.txt. So how should the app or the spin toml file be modified if a user does a spin add? And let me bring in this one in order to save again some keystrokes and format it nicely and bring in our specific spin toml SQLite database. We don't want to allow outbound host communication. Okay, so with that in place, I mean, it's pretty much the essence what's also listed in spin toml, missing like the overall application metadata, the spin manifest definition. So the components txt is the snippet that will be injected into an existing spin toml. So basically, that's us mimicking everything that we have in spin toml, but taking a subpath into context. And you saw that earlier when I did a spin new, used the empty template, and then added a new API component that resists in an API subfolder. And we have to respect that by providing a work dir over here and by pointing to the wasm file in dist in the source, in the output folder. Cool. So let's test our template. So to test our template, let's go to this folder and to my root folder. This is where my Git folder resists, and let's do a pwd over there. So we can take this path and say spin templates install steer and point to the directory that will later become, right, the root of our Git repository. Okay, we see installing a template CRUD.ts, and there should be a new CRUD.ts template right now in Spin CLI. So let's make an examples folder. Let's go into examples and let's do a spin new. There's CRUD.ts. Let's call it my CRUD-API. Description, my app. And we want to react to everything on the root route. Let's go to my CRUD API and let's open up VS Code. And as you see, we got a spin toml filled in all the details. We have a package JSON with our custom dependencies. And most importantly, we have our CRUD API implementation. We get rid of the squiggle lines by simply doing npm install over here or executing a spin build. It still has to pull the ET router. Now it pulled the ET router behind the scenes. So npm install did that. And we can do a spin build. Yeah, I'm on the wrong node version for this one right now. I'm on an older node version. And we can do a spin up. And our app is up and running. So the final step would be spin templates list to uninstall this one again. Where is it? CRUD.ts. Spin templates uninstall this. To go one folder up, remove my CRUD API and remove rf the examples folder. Oh, I'm in the examples folder. Okay, so let's see. Git add dot dry run. Okay, git add dot git commit sm add CRUD-ts template. So now it's me pushing this to my Git remote. Let me bring up my Git repository again. There we are. So we see there's the templates folder. Let's take this and let's say git templates. Oh, git templates, spin templates, sorry, install. And I think we don't have to use the URL argument. Oh, we have. -- help. Yeah, we have to point. Oh, from Git. Yeah, nice. Let's use Git. Git. And we can specify the branch. We don't have to. It's defaulting to head if we don't specify any details. Let's see. It's pulling my repository behind the scenes. There we are. And right now we can again do make examples and do a cd examples and do a spin new t CRUD ts, accept the defaults, hello world, cd into hello world, and take a look at source index again. And this is the source code generated by our custom template. All right, I know this was a lot. I thought it would be super helpful for you to roll individual templates for your teams to distribute them across your organization using either a file share. It could be as simple as that, right? Or by creating a Git repository and, giving your coworkers access to that Git repository and allowing them to pull your custom individual templates that align with your regulatory compliance to bring them to their Spin CLI to boost the developer productivity across the team even more. And with that, we're finishing this session in time. Last week or last for the last episode, we were a little bit over time, but this time we have a hard stop. So I hope you enjoyed this episode in which we rolled our own template for Spin CLI to improve developer experience even more and to create a tailored experience that helps you to build like different kinds of workloads with Spin and WebAssembly. I hope you already hit that like and subscribe button. If not, right now is the right time to do so. And we also hope to see you on the next episode of Fermyon Live. So with that, enjoy the rest of the day and see you next time. Bye bye.